Hi everyone, it's Caroline. I'm going to be talking about recent developments in BRUV technology. We've talked about BRUVs in this class before. BRUV stands for Baited Remote Underwater Video. It's basically a baited camera that's set up to record video and sometimes sound of marine species in the water column up to a certain detectable depth. This method's been used for a variety of studies, including shark identification, sex, size, abundance, behaviors. There's also plenty of studies that use BRUVs as a method for observing other pelagic species and their population dynamics, like tuna and snapper. I think this method's really interesting because it gives us a visual representation of what's going on under the surface of the ocean, as opposed to some other methods of sampling. But there's limitations to deploying these BRUVs. Until recently, the average battery life hasn't lasted very long. The average is about 60 to 90 minutes, and the storage is limited because of the amount of video data that's being recorded. So, within the last 2 or 3 years, a study was published on the abundance and diversity of blue sharks in a handful of locations within the Mediterranean. Instead of using the traditional BRUV that have the short-lasting battery life and the limited storage, the science team developed a system that kept the camera's battery charged up and provided a lot more storage, which allowed for recording up to 24 hours. The setup that they constructed also costed a lot less to develop. In total, the team spent about $1,000 on materials, whereas traditional BRUVs are a lot more costly depending on the materials that are used to construct them. But this method was purposely designed to be cost effective. So let's take a look at what this thing looks like. All right, over here on the right is a visual representation of how this time-extended BRUV was constructed. It's a floating mechanism. It's made out of a recycled surfboard that's anchored to an immobile object. Underneath, there's a weighted drum that hangs about 1 meter deep, and it houses bait that's inaccessible to predators. Over here, there's also accessible bait that's attached without hooks. It just dangles by clear monofilament. The inaccessible bait is for prolonged olfactory sensation, so even if the accessible bait gets chomped, there's still an attractant to the BRUV. One of the things that the study looked at was overfishing, and it was really evident that that's an issue in the Mediterranean. 3 of the 7 blue sharks that they captured footage of had residual hooks in their mouth, which is obviously a health concern, and it's an indication of overfishing, so it's definitely not good. Moving on, they mounted a Hero 3 with 256 gigs of memory, which is equivalent to about 27 hours of continuous high-def imaging. There's also an underwater white light right here. Both the camera and the white light are contained in waterproof housings, and they are both powered by a 12-volt battery that sits on top of the surfboard above the water. The battery stays charged by a 20-watt solar panel that's also mounted on top of the surfboard, and it's controlled by a voltage regulator right here that connects all the electronics of the system. This mast has a banner, a radar reflector, and another white light, and the purpose of this guy is just to deter ships from running over and destroying it. The underwater mast, this guy, is removable, so every 24 hours the science team could locate the BRUV and switch out the memory card. All right. The first extended time BRUV was deployed in July 2017, and the last was deployed in November 2019 for the study. Each BRUV deployment lasted between 2 and 5 days, depending on the location and the footage that each deployment captured. Most of them lasted for the full 5 days. And in total, this system recorded 1,355 hours of video between the 12 deployed BRUVs. That's a little bit over 56 days of footage. 52% of that footage was captured during the day, and the remaining 48 was captured at night. And of the footage, 7 blue sharks were observed more than once by the same BRUV deployment. They were able to record and observe behaviors. They were able to sex each individual. They determined the size of each individual by comparing the shark's body proportion to the inaccessible bait drum. based on how far away each object was from the GoPro in a given frame. They knew the dimensions of the bait drum. And they also were able to identify any special markings like residual hooks and leaders, scars, and natural or genetic indicators. One of the 7 sharks that they captured footage of was found with a hook in its mouth and a nylon leader that was longer than its body, so that's dangerous. What they found out about this population of blue sharks during this study was that, based on their observations and some calculations from previous data sets, the blue shark population in the Mediterranean has decreased by more than 95%, which is incredibly unfortunate for their population. They're now considered critically endangered in this region, and the authors of the study blame unregulated, industrialized fishing. The ability to record this number of hours of footage and only observe 7 returning blue sharks is evidence that there's a huge problem in this region, and it also provides evidence that fishing laws should be stricter and conservation efforts should be advocated for. All right. The authors conclude this article by talking about how there's a potential for the addition of a wireless video transmitter. And what this means is that it would allow video footage to be viewed and recorded in real time. So it's like a Zoom call with all the fish. How cool is that? I also like the setup for this method because it's easily customizable. If funds are available for better updates, storage can be increased, battery life can be extended, buoyancy and movement can be controlled based on what flotation device is used and the anchor system. The pieces can be detachable for easier access. There's a lot of wiggle room in how each of these BRUVs can be set up and deployed without sacrificing the quality of data that is being collected. The study specifically looked at blue sharks, but this method can be used for other species as well, including white sharks and more rare species that would be harder to observe with only an hour or 2 of footage during each deployment. This may be a good way to better understand population dynamics of a multitude of species that survive at detectable depths in the ocean using these endurance-based BRUVs. And with that being said, I'll hand it back over to my group. Thanks, guys.